In this video we will discuss options which are available for controlling pressure during calculations. How pressure changes during calculations is set in this section of the main menu. The current way pressure is controlled is shown by this blue label, which is currently keep constant, and the pressure value is 5 kilobars. So if we start calculations now, pressure will remain constant at 5 kilobars. There are two other options available in Petrolog for controlling pressure, and to access them we need to click on this blue label to bring up the pressure settings form. As you can see here, the other two options are either controlling pressure, change in pressure relative to change in temperature, or using steps in changing pressure, which is a way of controlling a change of pressure as a function of the extent of crystallization. So let's first consider the second option, which is change in pressure as a function of change in temperature. As you can see here, the units are bars over degrees. You would need to provide a value in here, and this value will remain constant during calculations. Let's consider a little bit what kind of values can be suitable. So depending on the starting composition, the change in temperature during crystallization can be 200 or 100 degrees, also depending of course on the extent of crystallization. It could be less, but it's unlikely to be over 100 degrees in many cases. And if the change in pressure is expected to be, let's say, 2 kilobars, so we are thinking of the ascent of magma from somewhere in the middle of the crust, about 5 kilobars, to shallow levels of about 3 kilobars. That is 2000 bars. So if you think of a change of pressure of 2000 bars over 200 degrees, this value will be 10. So the usual values which you would want to consider would be from single digit to probably 30 maximum. They cannot be higher, as that will lead to very fast decrease in pressure. Since during crystallization temperature is decreasing, dT is always negative, and it means that if the value you put here will be positive, the pressure will be also decreasing, so you would be modeling decompression of the magma, in other words magma ascent. If you put a negative value in here, which is also possible, you would model drainage of magma back into the plumbing system from a shallow level, so the pressure will be decreasing during crystallization, if that's of interest. The third option is effectively controlling pressure as a function of the extent of crystallization F. I've already filled in here the steps which are available in the current version of Petrolog. There are maximum 5 steps that you can use, and so in this particular case, at the start of crystallization, which is always 0, F0, we will be at 5 kilobars, and the magma will remain at the same depth while crystallization proceeds to 10% of the crystal. So when F is 10%, we still remain in 5 kilobars. Then in this particular example, we said that during the next 15% of crystallization, so when the amount of crystal is changing from 10 to 25, magma is rising from 5 kilobar to 3 kilobar depth. And then for the next 15% of crystallization, magma is remaining at 3 kilobars. And then we're saying that when the extent of crystallization reaches 50%, magma will rise to the surface. And then if crystallization continues, it will be occurring at 1 atmosphere. So these are the three options. Obviously, you can change those values. And if you would like a continuous ascent of the magma during crystallization, let's say you want to reach from 5 kilobars to the surface while magma is ascending continuously, all you would need to do is to say that here we will have 50 kilobar percent and the pressure is 0, and then all these values will be 0, which kind of tells Petrolog that you are not interested at using anything past that. So these are the options which are available for controlling pressure during crystallization.